The moon has held our imaginations for millennia. It has a historical and cultural significance that resonates with people. Anyone in the world can look up at the night sky, see the moon, and understand how amazing it is that a spacecraft built by humans is roaming around the surface. Lunar exploration began in earnest in the 1950s with the United States and the USSR developing and launching robotic spacecraft. In 1959, the USSR's Luna 1 was the first spacecraft to fly by the moon. In 1966, Luna 9 achieved the first soft landing, and in 1969, the US's Apollo 11 achieved the first human landing. In the decades since, many nations have contributed to lunar orbiters and landers. Today, interest in the moon is driven by similar goals as in the first space race more than a half-century ago, demonstrating technological capabilities and inspiring young people and the general public. However, the new moon race is not the private playground of the two powers. Now, many participants are in the Moonlander Club. For instance, early this year, a Japanese spacecraft soft-landed on the moon, making Japan only the fifth nation in history to achieve the feat called Smart Lander for Investigating Moon, or SLIM, the car-sized robotic lander, initially launched in September 2023, took nearly 4 months to slowly reach the moon's vicinity and finally entered lunar orbit on December 2, 2023. It then spent 3 weeks gradually lowering its orbit to just 15 kilometers in altitude before beginning its landing attempt on January 19. It is the second Japanese spacecraft to attempt a landing on the moon. The first, the Hakuto R mission from the Japanese firm Space, crashed into the lunar surface in April 2023. Only the US, the former Soviet Union, China, and most recently India had successfully landed on the moon before. The mission's primary goal was to test a new method for extremely precise automatic lunar landings, earning SLIM the nickname, Moon Sniper, at JAXA. The mission had a targeted site just 100 meters wide, in contrast with the kilometers-wide landing zones of previous missions such as the crewed Apollo landings. The demonstration of that pinpoint landing is the symbol of the project, says Yui Nakama of the European Space Policy Institute. SLIM sought to reach this precision by cross-checking its position against detailed mapping of the moon's surface by Japan's Kagaya orbiter and NASA's Lunar Reconnaissance Orbiter. Using onboard navigation cameras and autonomous image processing, the spacecraft continuously scanned the surface and identified craters and boulders to adjust its descent in hopes of a safe pinpoint landing. Having lowered its orbit to an altitude of about 5 kilometers, the spacecraft then began a vertical descent, free-falling to an altitude of 500 meters before firing its thrusters to hover and scan the surface below for obstacles. It next dropped to 50 meters and performed another hover and scan until tilting on its side. It fell to the surface from a height of 3 meters onto the slope of Shaolin crater. The touchdown should have been gentle because of the moon's weaker gravity, as well as cushioning from 5 small spherical shock absorbers. The whole landing procedure lasted 20 minutes, referred to as 20 minutes of terror, by SLIM's sub-project manager Kenichi Kasikian in a blog post last year, and was followed by an agonizing extended wait as mission controllers struggled to understand what had befallen the spacecraft on the lunar surface. Demonstrating such a precise landing could be a valuable tool for targeting regions at the moon's poles that receive permanent sunlight to prolong the lifetime of landers or for visiting scientifically rich locales, according to Asin Sky, who is part of the geology team selected by NASA for upcoming human landings the agency has planned for the lunar South Pole. It opens the door for going to more scientifically interesting places. We want to go to big boulders or rocks exposed in crater walls, but you've got to be sure you're not going to hit any of those on landing. However, things didn't go entirely to plan that day. It's been a wild ride for SLIM ever since it made a precise touchdown on the rim of Shaolin crater on January 19th. It ended up upside down. Images of SLIM taken by the baseball-sized robot rover Lunar Exploration Vehicle 2, or SORA-Q, which was released by the spacecraft just before landing, revealed that in achieving this precise landing, SLIM came down rotated at 90 degrees, effectively landing on the tip of its nose. Japan Times reported that SLIM project manager Niro Sakai explained that JAXA scientists believe that SLIM's strangely oriented landing came about as a result of one of its two main engines stopping during the 30 seconds or so of touchdown at an altitude of around 50 meters over the moon. This engine failure caused SLIM to drift 55 meters away from its chosen landing site. Without the glitch, SLIM could have landed as close as 3 to 4 feet from the selected region of the moon. The SORA-Q image shows the shift in position meant that SLIM sat down on the sloped ridge of a lunar crater. This incline caused the spacecraft to roll westwards onto its nose. But Japan Times added that Sakai said that the loss of the engine was the result of an undisclosed external factor, adding that a camera had captured an engine nozzle lying on the lunar surface. This statement really confuses everyone. What exactly is an external factor? We just don't know, and so people's imaginations go wild and plots appear in droves. Many scientists believe that the moon may be more than just a natural satellite. In fact, some go so far as to claim that the moon is an alien base. This conspiracy theory arose due to the existence of unusual structures on the moon. The surface of the moon is scarred with tens of thousands of impact craters of various sizes. Scientists suggest this is due to the fact that there has never been an atmosphere on the moon to protect it from bombardment by space debris. There are no natural erosive forces like wind or flowing water to affect its surface, and there is little geologic activity to conceal damage done throughout the moon's history. When you study the distribution of craters, you find the surface is totally saturated. That is, there are craters with increases in the number of craters right down to the smallest scale of size. One of the things that's really interesting about lunar craters is that even though some of them are very large, and some of them are very small, they all seem to have the same depth. This uniformity in depth is unusual on a planetary body where there should be a variation in depth. So why are the moon's craters so uniform? Well, it's really not explainable in terms of conventional or established geophysics. Among the most prominent anomalies is the Tau crater, renowned for its central peak that some researchers and conspiracy theorists suggest exhibits characteristics of artificial construction rather than natural geological processes. This hypothesis posits that such features could be remnants of ancient alien installations potentially serving as observatories or bases for monitoring Earth. The Tau crater's geometric symmetry and the unusual formation of its central peak continue to fuel debates among scientists and enthusiasts alike, challenging conventional interpretations of lunar geology and inviting speculation about the involvement of intelligent extraterrestrial beings. Another compelling lunar anomaly is the tower, a structure that gained attention after being captured in NASA photographs. Rising prominently from the lunar surface, the tower stands out as a starkly anomalous feature, leading to speculation and theories that it could be a remnant of alien technology. Some proponents of the alien hypothesis suggest that the tower might serve as a navigational beacon or a marker left behind by ancient extraterrestrial visitors, indicating points of interest on the moon or possibly even guiding interstellar travelers. The tower's mysterious appearance and its potential implications continue to stir curiosity and controversy, prompting calls for further investigation to unravel its true nature and significance. In addition to specific anomalies like the Tau crater and the tower, broader lunar features such as the Mare Orientale Basin also present puzzling characteristics that have fueled speculation about extraterrestrial involvement. Mare Orientale is known for its concentric rings and complex topography, which some theorists propose could be indicative of a massive spacecraft or a deliberately constructed lunar habitat rather than a natural impact basin. This hypothesis challenges traditional interpretations of lunar formations and invites exploration into the possibility of advanced extraterrestrial civilizations capable of engineering such colossal structures for their own purposes. The enigmatic nature of Mare Orientale continues to inspire debate and intrigue within scientific and enthusiast communities alike, underscoring the complexity of understanding the Moon's geological history and the potential implications for the search for extraterrestrial life. While these hypotheses about unusual lunar structures and their connection to alien factors are met with skepticism by many mainstream scientists, proponents argue that anomalies on the Moon warrant serious consideration and investigation. They advocate for a more open-minded approach to exploring the possibility of alien artifacts or structures, which could offer profound insights into the history of lunar evolution and potentially the existence of intelligent extraterrestrial life beyond Earth. The study of unusual lunar structures not only challenges our current understanding of celestial bodies but also raises fundamental questions about humanity's place in the universe and the potential for encountering other intelligent civilizations. Scientists expect a giant leap toward understanding the Moon in the near future when lunar exploration is undergoing a renaissance. Dozens of missions organized by multiple space agencies and increasingly by commercial companies are set to visit the Moon by the end of this decade. The NASA-led Artemis 3 mission will place the first human boots on the surface of the Moon since Apollo 17's Gene Cernan and Harrison Schmitt left the lunar surface in December 1972. The goal of the Artemis program is to establish a permanent human presence on Earth's natural satellite and an economy based around the Moon. Artemis 3 is scheduled for no sooner than September 2026. However, further delays are likely, and there are many more scheduled missions ahead of Artemis 3's astronauts. Scientists will pay close attention to 3 robotic missions launching later this year. The Japanese firm Space has a second private mission, called Hakuto Mission 2, scheduled to launch this summer. NASA is also preparing for a second attempt to land its commercial robotic lander, following the failure of Houston-based Intuitive Machines' first Nova-C mission earlier this year. But the most anticipated lunar mission is India's Chandrayaan-4 mission. Chandrayaan-4 will seek to follow the successful soft landing of its predecessor, Chandrayaan-3, on August 23 of last year, which made India the 4th country to land successfully on the Moon. For the first time, the mission will explore the lunar South Pole region, which holds large reserves of ice and water. Water on the Moon can be extracted for rocket fuel, and missions to the Moon could pave the way for future missions to Mars and other parts of our solar system. The discoveries will open up new knowledge and raise further questions, maybe about ancient alien artifacts. Please subscribe for more interesting videos and then leave a comments for suggestions and arrows. Thanks for watching.